Good morning, good afternoon, and good evening to everybody joining us on this power webinar, which is really financial modeling and Excel webinar, because financial modeling, we're going to be using Excel a lot. So financial modeling and Excel webinar. This is our September 2019 edition. We do this every month, third Thursday of every month from 11 a.m. to 12 p.m. After the recording, we'll edit it and then we post it on our YouTube channel. So if you go to YouTube, dbrownconsulting, you will see the content there. So welcome everyone. And today we were going to talk about optimization today, but last month we talked about debt calculations in financial models and had a lot of feedback that they want to see the full thing. They want to see how you calculate amortizing debt as well as bullet debt, and then how do you combine the two together when you have a model and you want to switch between the two calculations. So that's what we're going to do today. We're just going to go straight into a very deep demo. And also the last recording, we didn't record. There was a problem with the recording, so we couldn't post it online. So with this one, we'll post it online so everyone can get to enjoy it. Great, I think we're ready. So let me quick intro to myself. I'm David, and I am the principal managing partner for dbrown Consulting. I'm also an international consultant to the World Bank. I'm a Microsoft MVP, and I've been using Excel, doing modeling and all sorts for more than 20 years now. I'm a master trainer and instructional designer, and I also build online training videos and courses on officetraininghub.com. So you can check out officetraininghub.com. You should also check out dbrownconsulting.net. And you should also check out pbiusergroup.com/Lagos, which is our Power BI user group, and many other meetups that we also run. Great. So that's about me. And sponsoring this is dbrown Consulting. But if you're in modeling, if you like modeling or you do modeling, you should know about the Financial Modeling Institute. So they are a world-class body that specialize in providing the world with the financial modeling certification, which they've broken down into 3 separate certifications, which are Advanced Financial Modeler, AFM, you can call that level 1, Chartered Financial Modeler, CFM, that's level 2, and Master Financial Modeler, MFM, which is level 3. So the AFM, if you have the AFM, it means you can build any model from scratch. You can build any 3-statement model from scratch. So it's a very rigorous certification. Check them out at fminstitute.com. That's Financial Modeling Institute, which is fminstitute.com. Great. So what are we doing? What are we doing today? So let me just share my screen and we'll just jump straight into the demo. Great. So here we are. We have debt. Now, typically when you go to a bank, if you say go to a bank and get a loan from a bank, you could see that maybe a bank will look something like this. You take a loan and you want a loan for, let's say, 200 million. Well, this kind of debt is actually called an amortizing debt. I think it was a French invention. And why is this special? Because for this kind of debt, you want to just pay a fixed amount every month until you finish paying your debt. So to be able to achieve that fixed amount every month, or let's say fixed amount every year till you finish your debt, you're going to have to pay a certain portion on principal and a certain portion of interest, but you want that amount to be equal every single month. So what am I talking about? You take a loan of 200 million. At the end of the day, you must pay back this loan of 200 million. But in between, the person that gave you the loan, the bank or whoever the financier is, would need interest. So you need to pay them interest. You need to pay interest. Yeah. So how will that work? How would you be able to pay interest on this? Well, let's just look at some figures. So if you have your loan tenor, let's assume it's 6 years. Let me just increase this to 6. Say it's 6 years, right? And then your interest rate, let's make it simple, 10%, right? 10%. And your fees, let's just say they don't charge any fees. These fees have nothing to do with the loan calculation. These are just extra charges that they give you, which kind of increases the overall cost to you of the loan. So let's say there are no fees and there's no credit enhancement. So credit enhancement, you basically bring certain things that you help you reduce the loan value, or the loan, well, how will I call it, reduce the risk, right? So if you bring certain things that will reduce the risk to the financier, and we say that's a credit enhancement, and that will reduce your interest rate, right? So let's just assume there's no credit enhancement. Then the loan start period, of course, is going to start in period 1, right? And the loan end period is obviously period 6. So how do we do this calculation? So this is an amortizing debt. We're going to do this amortizing debt. We'll do a bullet debt calculation as well. So this is a bullet debt. What's the difference? Well, a bullet debt, you're paying off the principal at the end. So for amortizing debt, you're paying a little bit of everything, little bit of principal every single year. You're paying some part of this principal. So at the end, you now pay off this 200 million, right? And also you also pay interest as well. But the key here is you're paying a fixed amount every single month or every single period. You're paying a fixed amount, and that fixed amount contains some principal and some interest. For a bullet debt, you pay your interest every single month or every single period, and then you pay the whole principal in bulk. You pay the principal in bulk at the end of the day. So this principal is paid up at the end of the day. You just pay it in bulk. That means your bank schedule is not going to have separate interest or separate principal payments every single period. It's just going to pay the full thing at the end of the period. So that's how it works, right? So we're going to see how to do these two calculations, and I'll show you a very efficient way of doing both. Right, let's start with a simple calculation for amortizing debt. So if I come here, so this is my amortizing debt. How much am I going to pay back? So I'm going to increase some rows here. Let's just see some rows here. How much am I going to pay back for this debt? So total payments, right? So I want to know my total payments. And out of this total payment, I want to know how much of it was principal and how much of it was interest. So total principal payment, total principal paid, and then I also want to know the total interest paid, right? So if we do simple maths, let's say total payment. Well, the total payment is definitely going to be greater than 200, right? We know that. Total payment will be greater than 200 because, the loan is 200 and you must pay interest every year, and it's going to be for 6 years. So let's just do a guess. Let's say every year you're going to pay, well, let's say you pay a piece of, let's say every year you're going to pay a piece of this principal every single year. Let's say you'll pay off this divided by, let's say 6, right? So every year you're going to pay this, right? Every single year. But then over 6 years, you pay the whole thing off. So if you pay this every year, then interest is going to be, first of all, calculated on this value. Let's say this times, so I'm just doing a silly ad hoc calculation, right? Not silly, but back of the envelope calculation, right? So let's see what that gives us. So I press my F4. So it says 20. So I'm paying 20 in the first year. In the second year, I'm not going to pay 20 as interest. I'm going to pay maybe equal to this minus this, right? So I'm going to deduct what I paid off as principal, and then I'll pay 10% of this as interest. So my interest keeps going down, and then my principal goes down as well. But I'll pay, definitely for the first year, I'll pay 200 plus 20, 220. Second year, oh no, I won't pay 200 plus 20. I'll pay 20 plus this in the first year. And then something else with the reduced balance of principal. So it's a bit difficult to work with this, right? We'll need to know, let's build out a schedule. To be better to kind of build out a schedule. So what did we pay in the first year? What did we pay in the second year, and stuff like that? So let's say the schedule starts from 1st of January 2019 for example, right? 1st of January 2019. So what would we pay over 6 years? This is year 1, this is year 2, this is year 3. So we'll build out the schedule. But before we do that, let's see as a total, cumulative total, how much in total would we have paid? Yeah, what's the cumulative total we would have paid as a payment? So there is a function that gives us that. But before we find the cumulative total, why don't we say what are we paying on every year? What's our annual payment? Okay, what's our annual payment? How much would we pay every single year? Because for this kind of loan, you're paying the same thing every single year. So how much would we pay every year? Well, there's a function for that. It's PMT. PMT, if you read Excel, it says calculates the payment for a loan based on a constant payment and a constant interest rate. So, okay, I'll tab. Then I'll do Control A. So every time you do a time value of money calculation, you will see that you need to specify a rate, you need to specify the number of periods, you need to know what the present value is, what is the current value, what's the future value, and what type of loan is this? Do you pay interest at the beginning or do you pay interest at the end? Or what kind of loan? If you see type, it's a logical value, payment at the beginning of the period 1, payment at the end of the period 0 or omitted. So typically your loan, if you take a loan from a bank, is at the end of the month you keep paying. Well, in this case, at the end of the year, right? So what's the rate? So PMT calculates what's that payment that equates your principal and interest, that payment. So our rate is an annual rate. So let's just keep it annual. So this is our annual rate. How many, what's the period? How long is this loan? Well, it's 6 years, right? It's 6 years. What's our present value, which means what's the current loan they've given us? How much did they give us as a loan? That's this. What's the future value? Well, the future value is 0, right? Because at the end of the day, you don't want to be left with, then you want to pay everything off. So it's 0. If for any reason you're not paying everything off, then you could put the value there. What type? Type is also 0, is omitted, which means it's end of the period. So I can leave it blank. I can leave this 2 blank. Leaving this blank means 0, and leaving this one also means, oh, we're paying interest based on the ending value. So if I click OK, you will see that the payments, and again, I like to always have this figure as positive, is negative because that's money coming out of your pocket. I just want to show it as positive, so I'm going to put a minus sign. I'll just put a minus sign inside the beginning of the formula. Let's say that's minus sign, right? So this is going to be your payments every period. So obviously your total payments is going to be equal to, all right, this times 6. So 275, this is your total payment. So if I come here and I do something, there's some function called cum IPMT and cum principles. This is cumulative principal and cumulative interest. But look at what I did here. I said, since this is your annual payment, then this one should be your total payment, right? So let's see if that works. So if this is your total payment, let's calculate the cumulative interest and the cumulative principal and see if this formula at the top is correct, okay? So what's your cumulative principal? So we say cum, there's a function called cum princ, so cumulative principal, that's what it means, cumulative principal. We do Control A, right? So what's this? Cumulative principal says rate. What's rate? Rate is the interest rate. Okay, so that's this, right? Number of period, what's that? MPR is the total number of payment periods. Well, 6 is the total number of payment periods. Present value. Present value is the present value. Well, that didn't help. PV is the present value. Present value is the loan. So that's the beginning. That's the loan. Start period. Start period is the first period in the calculation. Well, that's year 1. Yeah, that period is year 1. End period. So you want to find the cumulative from the beginning to the end of the loan. So the beginning is 1, obviously, and then the end period is the last period in the calculation. What's end? So the last period is obviously the duration of the loan, which is this, right? So if I click OK, I should get, it says you've entered too few arguments. Oh, wow, that's because I didn't scroll down, guys. So there are some more things at the bottom, too few arguments. So I scroll down, you'll see that type is also required. So type is the timing of payment. So timing of payment, I'll put it as 0. Timing of payment, 0 means the end of the period. So I click OK. And guess what? The total principal paid is equal to 200. obviously we knew that, didn't we? We knew that that was the total period because guess what? We said we're starting from period 1 to period 6, right? 1 to 6. So obviously this is the entire loan tenor. So let's check cumulative principal. So if I come and say, hey, cumulative interest, cumulative interest, the function that does that is called cum IPMT, which means cumulative interest payment, right? So I do tab, Control A. Same kind of questions. What is the rate? What is the number of periods? What is the present value, which means what's the loan? What's the start period? I'm saying 1. And what's the end period? I'm saying is the full loan, so the whole period. Then I scroll down and I say the type is 0. So type is 0, and then it now calculates something. Let's see what it calculates. It says 75.53. What does that mean? Let's put a minus sign at the beginning so that we can see. So it says that the cumulative interest paid in that whole loan tenure is 75.53. Can you see that? So that means if this is the cumulative principal paid plus the cumulative interest paid, that means our total payment is 275.53, which is equivalent to our annual payment, which we calculated using the PMT function time, and then we now multiply that by the loan tenor. So this calculated this, but we're going to use this methodology here to build a schedule. So let's come into the schedule. So come down here and we build a schedule. So this schedule, we're going to have our beginning balance because this is a loan schedule, right? So we need to have our beginning balance. Let's just scroll down a bit. Let's see. Good. Okay. So just look down here, guys. Let me say beginning balance. Beginning balance. Then we have the repayment. Or should I even just say new loan? And we say repayment. But really, for this kind of schedule, you won't have your loan will just come in at the right time, and then you do your calculations, repayment, and then this is your ending balance, right? Great. So we'll do that calculation. Now, when does the loan come in? So if this is your historical, let's make this our historical value. Let's say the loan started in 2019. So I'm going to put 2018 here, okay? And so we need to know when the loan came in and then when it goes out and all that. And we need to know what periods we are in. So if you start this beginning balance, let's say this is our historical. These are all our historicals here. So I'm going to color this. I'm going to go to Home tab, come down here, and I'm going to pick a linked cell style. Yeah, this is a linked cell style telling me this is where I'm linking to, right? So the historical value of my loan. Now, this beginning balance is always going to be equal to last year's ending balance. I can put that. Then you have your new loan and your repayment, and your ending balance is simply going to be equal to your beginning balance plus your addition minus your subtraction, right? I can put a total style to this. Great. So there we go. So this is my simple schedule. Let me just scroll right up. Sorry, I have all this data. Let's just delete all of that. Clean that out. So what I can do is I can put a hard stop here so that I can always. Just gonna put a hard stop. Just hiding these columns. I did that by highlighting the column and then Control Shift 0. Yeah. Well, just Control Shift open bracket. All right. So let me drag this right. Control R. Right. So now, how do I know when my loan came in? When did the loan come in? When exactly did the loan come in? I'll have to find that out. And then also, I need to also find out what is my interest calculation, right? What's my interest calculation? Yeah. And how do I know when that happened? So when did my loan come in? When did we get this loan? Let's just assume for interest sake that it came in January. In what year did it come in? And let's say it came in at the first day of the year. So loan issue date is 2019, or a loan issue year. We could go precise and get the particular month the loan came in, but I'm not going to do that here. We can do that in another webinar where we do precise debt calculations, as in precise, very, very precise. That would be interesting, but not now. So when did the loan come in? Let's say 2019. So I'm just going to do a counter. And what do we do with the counter? I want to know exactly when the loan came in, right? And so my counter for a particular period, let's say counter. So this counter is very important. So I'm saying that this is my equals to this cell plus 1. So if I say equals to this plus 1, you know that this is period 1, yeah? So this counter, I want to know, okay, what period are we in? Forecast period. Let's just say forecast. Okay, forecast period. That's what I want to find out. So if this is my counter, this is 1. If I highlight all the way to the end, that is counts to your 1, 2, 3, 4, up to 10, right? So this counter is going to be used very soon. Let me just put it there. This just counts my periods. Now, if I want to do precise debt calculations, if my loan comes in 2020, then 2020 will be 1, 2, 3, 4, 5. We need some formulas, some very small tricks there, but we're not going to do that. So your new loan and your repayment, when did the loan come in? We're saying the loan came in period 1, right? So when did the loan come in? I can use another logic here and say, okay, when did the loan come in? Loan issue date. Oh yeah. Loan, or let's just say loan flag. Okay, let's just say it's a loan flag. So what's the loan flag? Loan flag is equal to this particular year. Let's even bring the year. We need to kind of bring what year this is. So if I can say, okay, what year this is right now, what is the year that I'm looking at? So what year is this? So if I say it's equal to year, what's the year of this cell? And equal to year to give me 2019, right? So I come here and say, okay, that's 2019. Those are the years. So if that's the year, then when was the loan granted? Loan issue flag, right? So when was the loan granted? The loan was granted. We say equals to, hey, this year, are you equal to when this loan was granted, which is this cell up here? Are you equal to that? And if you're equal to that, that means that's when the loan was granted, right? So I say true. So I highlight that all the way to the right. So that's when the loan was granted, right? You can say it's true. So if I say the loan was granted in 2022. So the loan was granted in 2022. You see that this is false, 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 and true is here. Yeah. If you don't want true or false and you just want it to show 1 or 0, you could just put it in brackets like this and multiply it by 1, right? So instead of true or false, it would just show 1 or 0. I Control R, and if you want, I could do something like this and say, hey, do you know what? I don't want to see the zeros. I just want to see, put a 0, semicolon, maybe -0, semicolon, and then I want to see a dash, just a dash instead of 0. So now I know when the loan was granted, which is here. You could also use true or false and do a conditional format. So if I come here and change this to 2019, see the loan was granted here. Why do I need this? Well, I need this so that I can come in here and say, hey, my new loan comes in equals to this flag multiplied by the actual loan amount, which is up here, right? That's what I'm trying to achieve. I'm trying to bring in the loan at exactly the correct time. So what that means is when the loan will just come in at the right time. So if I come in here, I can say, hey, do you know what? The loan came in 2021 for some reason. So if the loan came in 2021, look at it, it came in 2021. So the loan is active from 2021. All right. So if the loan is active from 2021, and how long is the loan duration? So what is the loan Is the loan active? Is it active, right? How do you know if it's active, right? So it's active. Let's see. Well, you know whether the loan is active if this is the loan issue year. When is the loan going to end? How do I know when the loan is going to end? Loan end date, right? Loan end date. How do I know when it's ending? Well, if it's issued here and it's for 6 years, it's going to be 2021, that's year one, up to the sixth year minus one, because it's going to include this. So if I come here and say, hey, this year plus the duration of the loan, which is this, right? The loan duration. If you notice, there's a lot of, when it comes to modeling, right? Prep time is a lot. You have a lot of prep time. So your loan is this, and I have to do minus one because it's going to include this year. So if you check that, 2021, 2022, that's 2, 23, 24, 25, 26. So this is the end date. So when is our loan active then? So how do you know when our loan is active? Well, that's why you can use this flag as well. I think I'm going to prefer, I don't want the ones, I prefer the trues and falses. I just like them. Prefer trues and false. Remember, true and false is the same in Excel. True is 1, false is 0. And why I like trues and falses is I want to use the flag style. Yeah. And for the flag style, I'm going to also put a conditional format to tell me when it's false, it should be red. Sorry, I just had a small break in transmission. So I'm saying to say, hey, when this is false, let it be red. So I'm going to put a new rule. And my new rule, format cells that contain or cell value is equal to false. So once my cell value is equal to false, I want you to format my fill where the pattern color is going to be a red pattern color instead of the pattern color we have here, which is green. And I say, okay. And you can see that the only one that is nice and green is this one that's saying, oh, the loan issue flag. So what about the loan active mask? I want to see a mask of when the loan is active. When is it active? So if my loan was issued in 2021, well, it's going to be active if, right? See, the first logic is obviously that my loan issue year, this is my loan issue year here, right? This is my loan issue year, right? I could give it a name if you want. I could call this issue year, right? Issue year, right? And then I could call this repayment here, or a loan, not repayment year, more like end date. I could just say end date or start date. I think end year, right? And then maybe I call this one start year. So that makes more sense. Start year. Well, issue year and end year. Well, it's not bad. So now let's see that. So here we're going to say, obviously, if you want to know whether the loan is active, the loan has to be the date you have here, or the date for issue. That means the issue year must be greater than or equal to the time period that we're currently in, which is this, right? That's one logic, right? That's one logic. Now, if I take this logic to the right, it will, well, first of all, that doesn't make sense, does it, right? This logic should be, no, it's the issue year, right? The issue year should actually be less than, should be before this, isn't it? So because what I want is true. What I want is true when the issue year is less than this, or when this is actually equal to or greater than the issue year. So it's the other way around. I should have done this logic, right? So it's this cell, right, equals to this cell should be greater than or equal to the issue year, right? So I close it, and then take it right. So you're saying, hey, the loan should be active here. But the problem is, when do we stop? The loan has to stop at a certain period, right? So we need to stop it. How do we stop the loan? Well, we need to add another, we just need to add another thing there. So multiply this by another check. And the check should be, obviously, when should the loan stop? It's when this year is greater than, yeah, because this year can be greater than or equal to the issue year, but we don't want this year to be greater than or equal to the end date. It has to be less. So we're going to say this year again must be less than or equal to, right, the end date or end year. Then we drag that, right? And you can now see the loan period. And then we could actually copy this conditional format, and then we could just paste this format there. So I just copied and paste special format, right? So paste special format. And obviously this format will have to change because it's not true and false anymore. It's ones and zeros. So I need to come here and do a conditional, manage the rules for the cell and edit it and say, hey, this is equal to 1. Yeah. So it's equal to 1 or not equal to 0. That's when I want it to be red, right? Yeah. So I apply, and you can see that right now we have when the loan came in and we have when it is active. Now, this is so important. This is so important. So when the loan came in and when the loan was active. So if this is our normal counter, we need to now have a counter for exactly when the loan period is active. So if I come here and say, hey, I want a counter for my loan, a proper counter for the loan, all right? We want a proper counter for the loan. How do we get this? So I want a counter for my loan such that I have 1, 2, 3 at the right time for the loan. Because right now this counter is fine, but it's only counter for my time period, which is this. I want a counter for this loan. So what I want to see is this 0, 0. Then I see 1, 2, 3, 4, 5, 6, 7. And then here I can just see 0, 0, 0, right? I'm not interested. So you get, so how do I achieve that? So many ways to do it, because this is 1, 2, 3, 4, 5, 6, right? When someone now changes the loan issue year to a different year, I want this 1, 2, 3s to automatically update. So the only time that this should kind of show anything is when we have a true here, right? And when it's false, it should just be 0. Do you get? That's really it. So what we do, we could try a normal counter first, say equals to this times or plus 1, right? Plus 1, yeah. Let's try a normal counter first, right? So you see the logic behind what we're going to do. So this is a normal counter. But really, this counter shouldn't work, right? So this counter, it shouldn't really work because currently the loan is not active. So if the loan is not active, so if I put this in brackets, right, so they can see it, this plus this, right? And then we now multiply this by this cell, which basically tells us whether the loan is active or not. I get 0. Now, if I drag this to the right, Control R, and you see that this is now saying, oops, sorry, F2. So this is now saying, hey, J30 plus 1 times K. So this J30 plus 1, this is 0 plus 1 times this, which this is supposed to be true, isn't it? So let's just check our format. Okay, I had an invisible format there so you can't see stuff. So let me just do Ctrl+Shift+1. It's just a formatting thing that made you not see. So you see, then it works. Because what I did is I'm just doing the normal counter, but this time multiplying it by whether the loan is active. All right, whether the loan is active. So let's test this. If I come here and I change this active loan to 2019, you'll see that our issue flag, this is when the loan was issued, and this is when it's active, and you can see it's counting 1, 2, 3 to 6 perfectly in the right spot. Why is this important? Well, it's important because we need to find out what the repayments are for a particular period of this loan, right? And how do we do that? We do that similar to what we did here. So let's see, what did we do here? How did I get repayment, principal repayment? Where is that? That's this one. If you look at this formula, we see that principal repayment is your cumulative principal, right? Your cumulative principal was looking at what? What was it looking at? It was looking at your total loan value, right? Oh, no, your interest rate. It's your interest rate up here. The number of periods for the loan, total number of periods, the present value, which is the loan itself, right? And then your start period. Now, your start period was 1. But really, for a start period was 1. So you want to get a cumulative between period 1 and period whatever your end period is. Now, if you look at this schedule we have here, for this particular year, my start period is 1 and my end period is also 1 for this period. Here, my start period is 1, or the cumulative for this, my start period is 2 and my end period is 2. So if I put 1, 1, let's just see what that does, right? 1, 1. What does 1, 1 do? It says, oh, you're paying off 25. If I do, my start period is 1 and my end period is 2, you look at that, 54, blah, 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 right? So this is giving my cumulative between period 1 and period 2. There is another function. This is instead of cumulative. There's another function called Prince, PPMT. So PPMT is your principal payment. So what's your principal payment? This is your principal payment. So your rate, your period, your number of periods. Now this also, you could use it to calculate the interest for a particular period instead of doing the full cumulative. So here you're saying, hey, give me the rate. What is the period? This period says specifies the period and must be in the range of 1 to NPR. Yeah, so specify the period. Specifies the period. Now, this number period is the total number of payment periods in an investment. So if I want to calculate for one particular period in time, which is what I want to do here, see the repayment, I'll say equal to, right? Yeah, so equals to, so what's my principal, which is my PPMT? Let's say PPMT, for example. What's my PPMT? So what's my PPMT for, that's my principal payment. Let's say tab, Control A. So what's my rate? So my rate is still this rate up here. I have to lock it. I should have brought the rate down there, but I'm just locking it. What is my period? So what period am I looking at? So the period is actually this guy here. This is the period. But how many periods is this whole loan itself? Well, that's this period here, the 6. This whole loan is 6 periods in total. What is the present value? Returns the PV. Is the present value the total amount that a series of future payments is worth now? All right, so what's the present value of the loan? So if you had, if this is the rate and stuff, this is the loan itself. Well, this is the loan, but that present value is actually the period here. But let's just see what this gives us. And then the future value, well, we don't know. The future value should be 0. The type, you just leave that blank. Let's see what this gives us. So this gives us 25. Let's make a minus sign there so we can just see that's a minus sign there. This 25 stuff, if I drag it to the end, it's supposed to give us the full 200, and we're supposed to have an ending balance of 0, right? Right. So if I take this and I drag it all the way to the end, let's see what happens. You see a num error, right? Now, we're going to deal with that num error, but these are the principal payments on every single period. Let's assume that our loan doesn't start in 2019. Let's say it starts in 2020. Let's see what's happening here. So it starts in 2020. You can see your num errors. Don't worry about that. But here is where it starts in 2020. And then you have all this. If I highlight all of this repayments, you'll see it's 200,000 repaid. So how do we stop this num error? Well, the num error will happen because using 0 is looking at 0 in the calculations and doesn't understand what can I do with 0. So here we could just put an if there's an error kind of thing, right? So if there's an error when you're doing all of this, please give me 0, right? So, and then we drag that all the way to the right, right? Right. So that's how you do that. And you can see that we can shift the payment period. We say the loan was granted 2021. 2021. And you'll see that it shifts nicely. So this is working. The payment is working. The repayment schedule is working fine. Using, what did we use here? We use the PPMT function, right? This place here, we use the cum PM, the prince, I think it's called cum prince function. Yeah, that's what we used here. Let me just confirm that. Cum prince, yes. And this was the cum IPMT function, which is the cumulative interest expense, to calculate the cumulative interest expense, right? Cumulative interest. So this calculates the cumulative interest expense. Right, there we go. Then this one calculates the cumulative principal. So I'm a bit lazy. Let me just copy and paste. Yeah. Let's calculate the cumulative principal payments. I think it's better to use payments in the other one. Right? There we go. Payments. Okay. Cumulative interest payments. Just make this small so it's not intrusive. Yeah. There we go. Great. And there we have it. So how do I now bring in the interest? So same thing we did here, right? Same thing we did here. I could just copy it and paste it, but let's just do it again. So I'm saying, hey, what is I did the PPMT here. So this was a PPMT function. That means your PPMT function. Here I'll need to use another similar function, but this time it's going to pull out the principal. We're going to do this two ways, actually. We're going to do method 1 and method 2. So we see interest expense. Let's just call it interest expense, right? So this is interest expense method 1 and interest expense method 2. So we can see how both of them work. So your method 1 is going to use this function called principal IPMT. So it's going to use IPMT, which means I want to interest payment IPMT function. So what does IPMT do? Let's have a look. So you come here and say equals to IPMT. It says returns the interest payment for a given period for an investment based on specific constant payments and a constant interest rate. Well, there we go. So here your rate is a constant interest rate, which is this, right? I'll put the F4 to lock it. I need to lock it. Your period is the period for which you want to find the interest. Now, obviously, this is the period because this is 0. That's what's going to cause problems in our calculations. You know, every model must be left to right consistent. The loan started from here. That's why the 1 is counting from here. But we're going to put it from every model. You build your formula for the first column and then you drag it right. So yes, we're going to have an error there, but don't worry about it. Number of periods for the loan, well, it's a 6-year loan, so that's this here up there, F4. Now, if it's monthly, it's exactly the same way you do this calculation. If it's monthly, it just means your rate, you must divide this annual interest rate by 12, and this is your number of periods, you multiply it by 12 to do the monthly calculation. Your present value is the loan itself, so we click it, and we lock F4, right? Your future value is going to be 0, we can leave it blank, and your type, you can see it's not compulsory we put anything there, so we can just leave it blank. So we're good with these calculations. We're going to get an error. Why are we getting an error? Because there's no formula. The 0 period doesn't exist. So we need to kind of put, first there's going to be a minus sign here because we want your payments to just show positive instead of negative. And then we put an if error. If you get an error when you do all this stuff, give me 0. We close our bracket, we drag it right. Drag it to the right, Control R, then it calculates something, right? Now, if you want to know whether method 1 is right, you will need to check what was the total payments method 1, right? What was the total payment for method 1? And remember, the total payment must be equal to what? This is our check here. This is the total payment here. This one. Let me just make that very nice and bold. This is the total payment. So what is our own total? So if I come here, I'm going to do a sum. I do an alt equal to, right? So I do a sum. What's the shortcut for sum? Alt equals to. So I sum this, all these values here. And you see that I have a total of 200. So what's going to be our total interest? So I just copy this. And what's our total? Okay, 75. And the total here is equal to this plus this. And you can see that that is 275. Perfect. So it works fine. So what's our total for method 2? We'll see method 2. We're going to do method 2. What is method 2? So method 2 just says, hey, you know what? If this is your, let me start from here so you understand. If this is your balance, maybe your balance at the end of the period, or let's say this is your loan. These two values are your loan, your beginning balance and your ending and your new loan. If that's the loan value, why don't we just multiply that loan value by the interest rate and we'll see how much they pay each year. So that's what method 2 says. So we say A equals to, give me the sum, right? Give me the sum of your beginning balance and your new loan, right? We're assuming the repayments are at the end of the year, so we're not adding those. And multiply that by, where is our multiplication sign? Multiply that by the interest rate, which is up here, right? So I do F4. Multiply that by the interest rate. So when I enter, you see it's 20. So if I drag right, you can see that it is the same thing. So this second method just works fine. Yeah? Second method works fine. And this second method, what did it use? It did just use beginning balance times interest rate. Beginning balance times your interest rates. So that's that method, right? Let me just make these smaller. And okay, let's make it red. It's fine. So you can see that's what we used there. And just go. Great. So that's what we used. And this summation, if I come down here, it's exactly the same. So obviously your totals, which is this plus this, is the same. And now this is how you build your dynamic debt calculation using amortizing debt. Yeah, this is your dynamic debt calculation using amortizing debt, where you have your year. You have to pick what year it is, the normal counter, which is just your normal 1, 2, 3s. But then you have your loan issue flag. When exactly was the loan issued? If you see the formula, that formula says, hey, were you issued in that particular year? When were you issued? Okay, that's the issue year. And you use a conditional format and a flag to show, okay, this is when it was issued. Then also you have your, hey, is the loan active? And for this one, you're checking the year you're currently in. Is it greater than or equal to your issue year? And is it also less than or equal to your end year? So this is a key formula here to say when the loan is active. And obviously, this is where the loan is active. Then you now come and calculate a counter for the loan, which means, okay, when did the loan start? And we need to do a running counter for the loan. And this is the tricky, simple calculation. You're just saying, hey, this cell to the left plus 1, but we're checking and multiplying it by whether the loan is active or not. So obviously, when I change the loan start date to maybe 2019, you'll see that, hey, the loan is now starting here. And how did it start here? Because we had a simple formula that says, hey, this issue flag multiplied by the loan. And so the money comes in at the right time. So this is everything for the loan. And if it was a historical balance, you could also put that there. But this is everything you need to be able to calculate your loan using amortizing debt. and you have all your flags and everything that works. For precision calculation, you're now going monthly. You're now going month by month. Let's assume that this was a yearly amount. You now need to find out how many months do you have in each year, and then how many months during the active period of the loan. So during this active period of the loan, how many months did it do here? How many months here? How many months here? How many months there? And you'd be very precise by month. You can even go to precision by day, but we're not going to go into that, maybe in another webinar. So this is how you do your debt calculation for amortizing debt. Your bullet debt is the same we did last month. We did that last month, the bullet debt in the webinar for last month. And then to combine the two, it's just a simple matter of having your schedules. This is your schedule for debt. And then you have another calculation below which you do as bullet debt. And you use a third section, which is a switch. So you say, hey, if the loan is bullet, pick from bullet. If it's not bullet, pick from amortizing. And that's the logic. It's such a simple logic to do. We'll probably combine the two and see how that goes if you want that. So this is our webinar for today. I hope you enjoyed it. It was very detailed. I'm sure you will need to review this. If you want to get a copy of this, you will need to just subscribe on our YouTube channel. Go subscribe on the YouTube channel, and then we would also share a copy on our website directly. So once this video is launched on our website, that's where you'll be able to get a copy of this spreadsheet so you can go practice with the video. Next month, we'll talk about optimization and see how that goes with real life problems. You can see bicycle, direct, meds. We're going to just see how does optimization work and how can we build an optimized model. We'll look at that one next month. Right. Thank you, everybody, for joining us, and I hope you enjoyed this webinar, and we'll see you next month.